Hello once again, our most valued student. My name is Confident and welcome to part 2 of our revision session for natural science. And as I promised you, I'm doing part 2 and this is going to prepare you as you prepare for your final June exams. This is only focused on chemistry and we're going to quickly look at this. And question 8, that's the periodic table. We're going to look at question 9 and we're going to end with question 10 and 11. So I was taking a bit of time in the previous section, but now I'm going to assume you did watch the first video because it lays a good foundation. Some of the things are just repeating. That's why I said when you do these 3 videos, you'll be in a better space to answer your questions. Now let's start with question number 18. It says periodic table elements and compounds. Here, first question, it says study the symbol, and then there is the symbol 1327, and use the periodic table provided to answer the questions. So let's go and identify this particular symbol in the periodic table. Am I right? So here 13 and 20 what? 27. Am I right? Look at this one, 13 and 27. If I increase, there it is. It's your aluminum. Alright, so the way they put it as is, okay, they just match 13 and 27. So what are they saying? Name the element in this symbol. It is aluminium. Alright, give the element its mass number. Come back to the periodic table. They even tell you the atomic, it says the approximate relative atomic mass is the symbol there, which automatically says that this is the mass, that's the mass number there. Alright, and then what about this one? Is the atomic number, or they gave us actually, there is the atomic number, which is the number of what? Of protons. This is proton number. Alright, so let's go back here. Give the element's mass number. What is the element's mass number? It's simple, 27. Give the element's atomic number. They just told us it's 13. Guys, you identify this from the periodic table. Give the period number where this element is found. And I told you in the periodic table, you've got 2 numbers. There is this one where you are looking at like this. 1, 2, 3. This is the group. So if you are saying group 1, group 2, group 3, it's like that. For example, magnesium here is in group number 2, but period, you are looking at it like this. Period 1, that's the start. Period 2, that's the second. Period 3. So you see, magnesium is in period 3. So let's see this aluminium, what period it is. If you can make it small again. Aluminium, there it is. I think you can see that aluminium. If I make it small again and make it straight, there is aluminium. It's period number 3. So they ask us about the period. So period number is period number 3. For what is this substance commonly used? Where do you use aluminium? Have you ever heard of aluminium windows, aluminium doors? So it's an open question for doors and windows, aluminium products. But one common one also in the food industry is the aluminium foil, aluminium foil. Remember when you are using it in the baking, you find, or wrapping of food stuff, they use aluminium foil. Alright, draw a labeled atomic structure to represent the element in your answer to question 8.1. I think we've done this again where we draw an aluminium, but let me do it here to say when you're drawing it, first things first, they want you to draw the atom aluminium Al, which has got 13 and these are 27. Now remember, you need to have the nucleus, so you surround with the nucleus, and it's telling you there are 13 protons. I told you these are protons, so you can come in and say, okay, let me do my protons, make them 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So if there are 13 protons, and you know that this one this 27 has got 13 protons. How many neutrons? Because it's protons plus neutrons. So plus neutrons. You see that if I say 14 here, it will be 27 at the end if I add. So which means neutrons are what? Are 14. So we can come here and say let's do neutrons. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It's not a must, it's 14. So this, when you label it, that's where the labeling comes. You can say this is the nucleus. Okay, let's make it a bit longer. Okay, alright, I'll label it far and say this one becomes the nucleus. Remember now on the key we called this one the what? The neutrons, and then we did this one as the protons. It's very important to have that key, protons. So that's the nucleus, and then in the nucleus you label and say this is neutrons, and then you label and say that one is what? Protons. Okay, this you put it in a box to say that's your scale. And then now what is left is the what? The electrons. And then let me erase here. Now the electrons is the same as neutrons. So the electrons, okay, let me not do it there. You do it here. See these protons, they are 13. Also it means electrons are also 13. Protons and electrons is the same number. Protons is the same equals electrons. So you start with 2 when you're drawing it. I'm supposed to make a nice round thing around here. So you start with 2. Oh, come on here. Let me try it like this, much better. So you start with how many? You start with 2. So you say I've got 1, 2. Remember there must be 13. Then after that you follow up with another ring that takes 8. Alright, so let's take 8 here. It's 1, 2, 3, 4, 5, 6, 7, there is 8. So 8 plus 2 is 10. Remember I need 13. So you have another ring again. The next ring also takes how many? It's supposed to take 8, but you count. So 2 plus 8, 10, 11, 12, and 13. That's it. And then you call this, you label it and say this is what? This is electrons. Electrons. If you can't sketch this, if you're confused with this, they will even give you a mark if you do this. You say like this, and then you say in an exam with a pencil, and then you do this and say in here electrons, sorry, you say protons. This is when we are allowed to do that. And then you say here neutrons, and then you say this becomes, you label it the nucleus. Then it makes the what? The nucleus. And then after that you do this, you just do this, and then you say here these are electrons, or you put negative here, you put just the negatives, you do this. Like that, they will still make it correct, and then they say these are electrons. Just fine, you don't have to be sensitive about it. Eh? Then it says use the symbols for the elements to write the formula of the following compounds. Ammonia with a ratio of carbon atom to 3 hydrogen atoms. Carbon atom, so carbon is to hydrogen, so 1 is to 3. So write down to what? They say ammonia. Okay, I think they made an error. It's supposed to say nitrogen. Ammonia is made up of nitrogen, but anyway, carbon to 3. So this one becomes now CH3. If it was ammonia, the actual one is supposed to be NH3. Alright, so they made an error. Sodium chloride with the ratio sodium, it's Na is to 1. 1 sodium is to 1 chlorine. It's Cl. So 1 is to 1. So it's sodium chloride. There it is. That's the chemical symbol there. Alright, moving on. So let's take it further. Acids, bases, and pH values. Well, moving on to question 9. It says Vossy investigated the reaction between hydrochloric acid, there it is, and sodium hydroxide. Hydrochloric acid, you must know this formula as HCl. And sodium hydroxide, you must know this formula NaOH. That's sodium hydroxide. Now, this is hydrochloric acid. You see, this is an acid and this is a base. You must remember such. Or it is alkaline. That's why they react. He puts 5 ml of what? Of hydrochloric acid into a beaker and adds a few drops of universal indicator. He then adds hydrochloric acid slowly until he is sure that the pH solution is 7. Predict the color of the solution after he first added the universal indicator. So what he has is, look at this. He has something like this. Let's say he has a flask, and in the flask, the first thing that he has is sodium hydroxide. And then this sodium hydroxide, if you put in a universal indicator here, this universal indicator, you put it in here, and then it's here, you shake. What is going to happen now? The color, you first edit, predict the color of the solution. So when you add it here, because it's sodium hydroxide, remember the pH scale, as I did in the center, we said it's 7. What color is it? It's green. And then the extremes here, this is acid, this is alkaline or base. So here it's purple, and this side it's red or orange. Alright, so what color do you think it will be? This will become purple. Oh, not purple, purple. Right? More purple or dark blue, somewhere there. Purple, I think that's the best. Alright, purple color. So here you're gonna say it's purple. Name the reaction that occurs between an acid and an alkaline. Acid and a base is called neutralization reaction. It's neutralization. Reaction between an acid and a base, don't forget, is neutralization. Write a balanced chemical equation for the reaction is 2 marks. So what are you having? You are having here a hydrochloric acid plus sodium hydroxide, which neutralization, you form a salt, which is sodium, say sodium, and that Cl, it's called sodium chloride. This is the salt. When you neutralize, you always form water, H2O, and that is the water where you are mixing this H and OH. Say H12O, that is it, which is water. So an acid plus a base is equal to salt plus water. That is a neutralization reaction. Alright, suggest how Vossy will know when the pH was 7. So how will you know? When it changes to what? There it is, to green. When the color changes to green. So that's why when color changes, when green color is seen, or when the color changes to green. Alright, and then says in this reaction a salt is produced. Remember, I would say it is a salt. Apply your knowledge to name the salt. There is the salt. What do you call the salt? This salt is called what? Sodium what? Chloride. That's your table salt, the one that you use in the house. It's sodium chloride, the one that you use in the house in your salt shaker. Is and then he says, is this reaction okay? First, he wanted a dry sample of the salt produced after the reaction. Suggest how he will do this. A dry sample. How will he try this sample? You evaporate. It's evaporation. You evaporate the water. Here, evaporate the water, or the liquid, the water, to remain with salt. You evaporate the water to remain with salt. Alright. And then says farmers need to know the pH of the soil to determine what crops they should grow. Look at the table showing the different pH values of some of the croplands will grow. pH: beetroot and mint 8, beetroot mint 7.5, carrot, lettuce and onions, cauliflower, lettuce, cauliflower, potato. In what pH range does potatoes grow well? Potatoes, there is the range. No, so you start from the smaller number, 5 to 5.5. Don't say 5.5 to 5 now. If a soil had a pH of 7.6, right, which crop could be grown? 7.5, somewhere there is beetroot and mint. What can a farmer do if his soil has a pH of 4? Now pH of 4 is somewhere in this range, right? So you see that nothing can grow here, but you want it to be like this. You add what? You add alkaline. Add an alkaline substance. Like what? Like lime. Lime is the most common one. From limestone. Lime is alkaline. Then it will make this pH start becoming higher, 5, 5.5 and stuff like that. Alright, so that is that part. We continue almost to the end. A reaction of nonmetals with oxygen. When carbon is burnt in air, burning, when carbon is burnt in air, so it's carbon. Now what do they talk about? Air. Air there is oxygen. Right. A colorless gas called carbon dioxide is formed. Give the word equation for the reaction of carbon in air, guys. Carbon plus that air is oxygen. What do you get? They say to get a colorless called carbon dioxide. That's what they are saying there. And then give the chemical equation for the reaction. Carbon stands for C plus oxygen stands for O2. And then what do you get? You get carbon dioxide. It looks like that. Simple like that. Carbon plus oxygen is called carbon dioxide. Draw the model picture equation for this reaction. Now they make it 3 marks. The model and picture for this reaction. What we can do, I think we can look at this and say this is carbon. We can have like this, the model. Let's say this is carbon, alright, plus oxygen. I can use like this. This is diatomic. This is oxygen. And then what do I get here? It's carbon dioxide. Now this is how you have for that. You have oxygen, and then you have our carbon. I mustn't make it big, let's make it the same. Our carbon, and then you have what? You have the oxygen on this side. See, there it is. Carbon is C, remember? This is C, this is O, this is O. Like this, meaning CO. There are 2 of them. That is how it looks like. Are you with me? Next question. Let's be done there. I hope, guys, this makes sense. Alright, next one. It says reaction of metals with oxygen. It says when magnesium is burnt. Now we've got magnesium, which is Mg, is burnt in air. When they say you are burning in air, oxygen is the one that you are using. It forms what? Powder. State the gas with which magnesium reacts. It's oxygen. Air means oxygen. I don't know why they asked this question, because if you could picture it here, when carbon is bent in air, the moment you say bent in air, if you can answer this one, oxygen, you can also answer this one. State the gas with which magnesium reacts. When you are bending in air, you are reacting with oxygen. Write down the name of this type of rapid chemical reaction that produces heat and light. What is this name? Write down the name of this type of rapid reaction. It is called combustion. It's burning. It's combustion reaction. Whenever you are burning, it's called combustion reaction. This name the type of rapid chemical reaction. It's a combustion reaction. And then they say write the chemical equation for this reaction. Guys, it's the same: magnesium plus oxygen. What you get now, careful, it's magnesium oxide. That's where things change. Now look, how many oxygen do we have? They say chemical equation. Okay, write down the chemical equation for this reaction. Alright, how many oxygen do we have? We have 2 oxygens, you can say. Here it's 2, but here we have got like a 1. So what do? I put a 2 in front so that there is 2 oxygens to balance that 2. See, so here we have got 2 oxygen atoms. Even here I've got 2 oxygen atoms. But look at magnesium now. There are also 2, but I started with 1. So I also put a 2 there. Don't put 2 here. This thing does not exist. As I told you, don't create some nuclear bombs by writing strange formulas. You need to write in front. Numbers are written in front. This is 2 atoms of magnesium. They need 2 atoms of oxygen to form 2 molecules of magnesium oxide. See that? That is that. Then they say here, write down balanced model or picture equation for this reaction. 4 marks. It's the same thing that you do there. Nothing changes. You come in and say, okay, magnesium, it's 2. So take this as 1 magnesium. It's not diatomic, it's separate. 1 and 2. There is the magnesium. 1 magnesium, 2 magnesium. But oxygen, remember, it's diatomic, meaning it exists as one thing. Then you can do this for your oxygen. So you say plus, then what do you get? You get magnesium oxide. Look at this, it's 2 of these. So you have your red magnesium, and then you have your oxide like this. That's the first one. Then you have a second one because there are 2 of them. See, that 2 in front, and then like this. Then that becomes the answer. That's why we're saying here, what is the formula? 2 of magnesium. If I can say this is Mg, you see, magnesium, and then this is oxygen. This is O and O, and then MgO, MgO. I think that. But okay, I forgot something here. You will say, yes, you forgot. What is it? I forgot the key. The key. So you must do this and say, this one here represents Mg, and then you say this one represents oxygen. Alright, so that is very important also. Then you can put the key in a kind of a square like that. So guys, that is that part. Now what is it next? This is the end. What is the next lesson? The next lesson comes here. This is the next lesson, which I want definitely to join. This is the next lesson. Look at it. I'm also going to look at this. I'm going to look at this. I'm going to look at this, and it continues, and then that's the end. So you need to get hold of the next lesson if ever you are interested in making sure that you pass your natural science, especially the chemistry section. We've come to the end of our lesson. Thank you.